Hello everyone, welcome back to Quadratic. So today's video will be focusing on this year's trial paper for Sabah paper 2. So for this paper, I feel it's not difficult, but it's challenging to solve the question completely. Because for some of the questions, it needs more time and more working than usual to get all the marks and to answer the question. So for other state papers, right, they have the similar questions but then less working but still get the same marks. So I feel for Sabah students, it's a bit unfair for them lah. Okay, and when I was doing this paper, I was a bit demotivated because again, more working to be done than usual. So I need to self-motivate myself, like telling myself, you can do it for some of the questions lah. So if you all have a similar situation as me, I think we need to have some right mindset and some positive thinking and self-motivate ourselves when we are going through the paper lah. Okay, so without wasting time, let's discuss this paper together. So this paper starts off with a question from functions, and here our function is a fraction, and here it says x cannot be p. So means that if the value of p is put inside this fraction, it will cause it to be undefined, which means no answer. So now in part A, we need to find this value of p. So the only way that can cause this fraction to be undefined is the denominator here becomes 0. Alright, so to find this value of p, we are going to equate the denominator with 0 and find the value of x that cannot be put inside this fraction. Otherwise, it will become undefined. Right? So the answer here is negative 2 over 3. So this would be the value of p. Alright, and for part B, it says we need to find the value of k. So value of k is at the numerator part of the fraction if f of 1 maps onto itself. So what does maps onto itself mean? So it means that the object would be same as the image. Right, so let me give an example. So now our value of x is 1. Right, so this value of 1 is our object. So if this object is put into the function, the output or the image would be the same as the object, which is 1. Okay, so to find the value of k here, let us use x equals to 1 first, so all the x here will become 1. Alright, and then we know that if 1 is put into the function, which we see here, the output would become 1. So for this part on the left side, I would change it to 1. Okay, and we can rearrange this equation to find the value of k, which is 4. And for the last part, we need to find the inverse function of f of x. Okay, so to recall back the steps, what we need to have to inverse a function is these two assumptions. Alright, which is y equals to f of x and x equals to f inverse of y. But just to let you know, the second assumption actually comes from the first assumption, because if we move the f to the other side, right, so it will become f inverse of y, and on the right side is just x. So if you compare this and this, it's actually the same. Okay, so the second assumption actually comes from the first assumption. So now for the steps to inverse a function, usually it would be best if we have a special way or a memorizable way to memorize these steps. Okay, so for me, what I would do is to memorize it using a real life action that we do often, which is washing clothes. Alright, so let's say this dirty shirt is this function, right? And this dirty shirt, outside and inside of it are dirty. Okay, so there are two sides that are dirty, outside and the inside. Okay, so this dirty shirt would be our function here. And for these two assumptions, I'm going to memorize it as they are the soaps. Okay, so now our goal here is to clean this shirt on the outside and the inside. Okay, so there are two sides we need to clean. Right, so the first step to clean this shirt is to apply the first soap to clean the outside of the shirt, right? So the first step is to apply the soap. So back to our function here, what we are going to do is to apply the first assumption inside here. So f of x becomes y. Alright, so once the outside here is clean, then we are going to flip the shirt inside out. So here, we are also going to flip this equation. So instead of y is on the left, we are going to put x is on the left. Okay, so we need to rearrange this equation to make sure x is on the left, everything which is not x to the right side. Okay, so now you can see that instead of y is on the left, now it's x is on the left. Okay, so now we can apply the second soap to clean the inside of the shirt. So back to here, we are going to apply the second assumption, which is x changed to f inverse of y. Right, and the last step, so now we have cleaned the inside and the outside of the shirt already, so we can flip it back. Okay, so for the values of y here, I'm going to flip it back to x. Okay, why flip it back to x? Because initially it was x. Okay, so now from y, we need to change it back to x. Okay, and there's another thing which is required here, which is to state the value of x, which can cause this fraction to be undefined. Okay, so to find this 1 over 3 is the same step as part A. Okay, so equate the denominator here with 0 and we can find the value of x already. Okay, and just to let you know, if we don't write this value, this answer, we would be deducted 1 mark according to the answer scheme given. Okay, so please take note on this. We need to remember to write the value of x that can cause the fraction to be undefined. Okay, so this is just the first part of this question, and now we have the second part, which is to find the range of f inverse of x if the domain is from 1 to 3. Okay, so this one, I think it's just quite simple. We are just going to put the lower value of x and the higher value of x inside this function. Okay, and then we find the value. And now we need to find the range of f inverse of x, so we are going to use back this form. So instead of x in the middle, we are going to put f inverse of x on the middle. Sorry, in the middle. Oh, and sorry, this one should be f inverse of x, not fx. Okay, and the lower value between these two numbers, I'm going to put it on the left side, and the larger value, I'm going to put it on the right side. Okay, and this would be our answer. For our next question, going into coordinate geometry, and in part A, we need to find the area of triangle AOB, which is technically this one. Okay, so to find areas in the x and y axis plane, we are going to use this shoelace formula to help us. Alright, so very simple, we are just going to substitute the coordinates inside this formula, then we can get the area. Right, as you know, we have two ways to substitute the values. So one is using the anti-clockwise way and the other one is the clockwise way. So usually I would recommend students to use the anti-clockwise way because the value that it will come out is positive. So I would always avoid using the clockwise way because it's negative, and usually for negative values we will do more careless mistakes. So for example, we forgotten the negative. Okay, so I always recommend students to use the anti-clockwise way. Alright, so now going back here, to start off to find the area, we are going to multiply 1 over 2 first. So please remember this 1 over 2. Okay, and then we are gonna select the starting point. So let me select point A as our starting point. Okay, so we are going to substitute the coordinates here. And now we are going the anti-clockwise way, so we are going to point O, or the origin, so the coordinates here is 0, 0. And from O we are going to point B, which is negative 6, 2. And we are going back to our starting point. Okay, so here would be the coordinates of A. So coordinates of A here will repeat twice. Okay, and please remember to go back to the starting point. Alright. So now for this part, we are going to cross multiply the values. So for the first set of values would be the top left value multiply with the bottom right. Okay, so negative 3 multiply 0, 0 multiply negative 2, and 6 multiply 4. Alright, then later on, the next set of values would be the bottom left value with the top right value, and we are going to multiply them. Right? So these set of values, once we multiply, we are going to minus with these values. Okay, so these two set of values will minus with each other, and then we will get these two sets of answers. Right, so this value, once we calculate, it would be positive 18. Alright, because we are using the anti-clockwise way, that's why the answer is in positive. Okay, so 18 divided by 2, and then we will get the area, which is 9 units square. And just to let you know that this part will contribute 1 mark. Alright, and as you know, for 1 mark is also very important in Addmath, so please do write out this working for every single value here, because we want to prove that the way we multiply is correct. Okay, so now in part B we have this point C, and it divides the straight line AB, so divides meaning separate, okay, using this ratio. So as you see this point C, it divides one line to become two lines. So line AC and line CB. Okay, so to find coordinates of this kind of points, we can use this formula to help us. Right? As you see here, the point divides the line. Alright, so we are going to use this formula. So the way to substitute the values here into the formula, we can use a very well-known way, which is to cross multiply the values. So meaning the value on the right side, which is 2, I'm going to multiply with the coordinates on the left, and the value on the left, I'm going to multiply with the coordinates on the right side. Okay, so the value of n would be the value on the right side, so n is 2. And then I'm going to multiply with the coordinates of point A. And then I'm going to add the value where the left side value, which is 3, or known as m, multiply with the values or the coordinates on the right side. Okay, and for the denominator, we are going to sum up the m and n, which is 5, and then we simplify, then we can get the coordinates. For part C, it says that this point P moves in a way that the distance from A is always twice the distance from B. Okay, so means that this point P is further away from A. So point P can be somewhere here. Alright, so example, if let's say the distance from P to B is 1. Okay, oh sorry, I should use the other color. Then the distance from P to A will be double, which is 2. Okay, so now we need to find the equation of locus of P. So recall back, equation of locus, we have two cases. So either it's one fixed point or two fixed points. So in this situation, we have two fixed points, which is point A and point B. So we are going to use this one. Okay, but this formula is not given in the formula sheet, but I want y'all to, instead of memorizing it, we understand it. Okay, so for each of the side, which means the numerator and the denominator, they are focusing on one fixed point. And for both sides, we are just finding the distance. So for example, the numerator part, we are going to find the distance of point P and the first fixed point. Alright, so to do so, we are going to find the differences between the two x coordinates first. Okay, but just to let you know, this point P, we don't have the coordinates yet, so this will be just x and y first. Okay, so to find the difference, it's just x minus 3. Okay, and then we find the differences between the y coordinates, so it's y minus 4, and then we are going to square them, add them up together, and then square root to find the distance. So on the right side, we are going to find the distance, which we have already found, which is 2. Okay, so this is just focusing on the distance from point P to the first fixed point. Then for the denominator, we'll be focusing on the second fixed point. Okay, so everything here is just the same, it's just the coordinates is different. So we are going to find the differences between the two x coordinates, and then the difference of the y coordinates, square them, add them up together, and then square root, and on the right side we are going to put the distance, which is 1. Okay, so now once we have this, then the rest of the steps is just simplifying. Okay, so here what we are going to do is to remove the square root first. So for both sides, I need to apply square. Okay, so for this square will apply to both of the square roots here, so both square roots will disappear with the square here, and then I'm going to square the value on the right side. So here will be 4. And on the left side, I have expanded the brackets, so it will be something like this. Okay, and to simplify even further, I'm going to move the denominator to the other side, so means all the values here will multiply with 4. Alright, and what I'm going to do is I'm going to move all of these values on the left, alright, to the right side first, because all these values are bigger compared to the left side. Then what I'm going to do is to switch the places from the left to the right, right to the left, so it will be something like this. Okay, but this is not our final answer yet, because as you see, all the values here can be divided by 3. Okay, so we need to divide the whole equation with 3, and we can find the final answer. Next question focuses on quadratic functions, and here we have the shape of the train's equation, which is this one, and describes this line. Okay, this curved line. So now we need to find the depth of the drain, which means the distance from the floor to the minimum point of the drain. So what we can do to find the depth is to find the minimum point of the drain first. So to find the minimum point of the drain, we can use completing the square, but since here doesn't say use completing the square, so we can use an easier way to find the coordinates of the minimum point. So the easier way would be we focus to find the x coordinate of the minimum point first. Right, so recall back, the x coordinate of the minimum point describes the axis of symmetry, or meaning the middle line of this curve, or the middle line of this drain. Okay, and to find the value of the axis of symmetry here, it depends on the x-intercepts. Why does it depend on the x-intercepts? Because this line you can assume it's like the midpoint. Okay, the middle of the two x-intercepts. So if we can find the value of these two x-intercepts, we average it, then we can find the value of the midpoint. And this midpoint is the value of this middle line, the value of the axis of symmetry. So now to find the x-intercepts, very simple, we can just substitute y with 0, right? And I want the value of x squared to be just 1, so the whole equation here I need to divide with 2/5. Okay, so this will be the result, and now I'm going to factorize this quadratic equation, and using a calculator, find the two x values, right? So the two x values is 5 and 25. So if we draw onto this diagram, it will be something like this. Alright, so now if you see, there is a little bit weird in this diagram, because the difference of 25 and 5 is 20. It is lesser than the width given here, which is 25 cm. So means the x-axis is not the floor, which means this x-axis should be the bottom of the floor. Okay, why is it bottom? Because the difference of these two values is 20 cm. It's shorter than the given length here, so it will be below the floor. Okay, so now to find the depth of the drain, we need to split this arrow already. So we need to have two ways to find the depth, which is the distance from the x-axis to the minimum point of the drain, which we are doing now, and the distance from the floor to the x-axis. Okay, so this is the tricky part of this question. If you didn't find the value of x-intercepts, you wouldn't know we need to split into two parts. So this is another reason why we don't use the computing the square method, because we can only find the minimum point, but we are unable to find the x-intercepts. Okay, so if we use that way, we are unable to know that we need to split them into two parts. Okay, so now coming back to find the x-coordinate of the minimum point. Okay, so we have the x-intercepts already, so let's find the average between these two values. Okay, so it's 15, so our middle line of the drain is 15, which means the axis of symmetry is 15, which means the x-coordinate of the minimum point is 15. Okay, so now with the x-coordinate, we can just substitute into this equation, find the value of y, which is negative 40. Right, so the value here would be the distance from the x-axis to the minimum point of the drain. Okay, and why is it negative is because it is, okay, actually this point, the minimum point is below the x-axis, that's why it's negative. But for our answer, we can just ignore the negative because we are just finding the distance, which has to be positive, right? Okay, so one part done. Okay, so now the part above is we need to find the distance from the floor to the x-axis. So here, let's find a point on the floor, and then let's find its coordinates. So here, let me try to find the coordinate of this point, the left end of the floor. Alright, so to find the x-coordinate, this one we can use the middle line, and since we have the length between the two ends of the floor, so here we can split this 25 into 2. So means if I want to find the x-coordinate, it will be 15 minus this part, okay, which is 25 divided by 2, and we will get the x-coordinate. So here will be 5 over 2, and now to find the y-coordinate, very simple, substitute this value into the equation. Okay, so means the distance from the floor to the x-axis is 22.5. So to find the depth of the drain, we just add these two values lah. Okay, which is 40 plus 22.5, then we can get the answer, 62.5 cm. Next question coming from progressions. In part A, they tells us to prove the SN formula for arithmetic progression. Okay, so what we know about Sn is it is a sum of the first n terms, so meaning it is t1 plus t2 plus t3 until the value of tn, right? So these are the first n terms and we add them together. This is what we know. So now to prove it, what we are going to do is to transform each of the t's here by using the formula from tn. Okay, so for example, t1, the value of n is 1, so here would be a plus 1 minus 1b, so 1 minus 1 is 0, so it would be just a. Alright, For t2, 2 I'm going to substitute into n, so here will be a plus 2 minus 1d. So 2 minus 1 is 1, so it's just a plus d. Okay, and for t3, same thing as well, 3 put inside n, so here is a plus 3 minus 1, so it's 2d, and so on. Okay, so all the red values here, I'm just going to substitute inside n to find the result. So the next step would be to group the unknowns. So what I'm going to do is to group the values of a first. So as we know, for each term there is an a. So here if we have n terms, this means we have n of a's, right? So to find the total number, it will be n times a. Alright, for the value of d, I'm going to group them in this way first. And now let me compare with the formula here. For part d, we have bracket n minus 1d, which is the value here, as you see at the end of the bracket here. So what we are going to do is, we are going to add the values here to form n minus 1d. So for example, the value d here, I am going to add with n minus 2d. So means n minus 2d, if I add d, here will become n minus 2 plus 1, which is n minus 1. Right? The same value here, and the same value from the formula. Okay, so another example, this 2d, I am going to add up with n minus 3d. So n minus 3d, if I add with 2d, it will be n minus 3 plus 2. Where is my arrow? Wait, okay, n minus 3 plus 2. So here it's n minus 1 d. Okay, and I am going to do it for the rest of the values here. Alright, so in summary, all of these values, okay, so all of these values, every two terms, right, every two terms, it will form 1 n minus 1d. Okay, so to simplify this part, what we are going to do is to find the number of terms that has n minus 1d. Okay, so here in total we have n minus 1 terms, right? So we are going to exclude this value because this is for tn. Okay, so we're going to start off with n minus 1, and here we are going to exclude t1 because t1 doesn't have d, so it is not inside here. Alright, so we are going to minus 1. And just now we have said that for every two terms, it will form 1 n minus 1d, right? So the number of terms, or the total values that we can get n minus 1d, is dividing with 2 from the total terms here. Right? Because again, every two terms, it will form 1 n minus 1d. So the total terms here is this, n minus 1 minus 1. So divide by 2, I can get the number of n minus 1d's. Okay, and also don't forget the value at the back. Okay, it is also one of the values that we have. So the number of terms here, we need to add 1. Okay, this one is actually here. Okay, so now with the number of terms here, we are going to multiply the value that we have formed, right? Which is n minus 1d at the back. Right? And then we simplify this one, we can get n over 2. Sorry about that, let me erase this. Okay, so n over 2. And now you can see that in this bracket, we need to factorize this n over 2 out. So what we are going to do is to divide the whole equation here with n over 2. And we will get the Sn formula. Alright? And for part B, we have a situation which is this bakery sold 500 cakes in the first week. So this is actually our first term, right? Because this is the first week. So first term is A, and A will be 500. Okay, and then in the second week, it says that the sales declined by 10 cakes compared to the previous week. So means if you want to find the next week's sales, we need to minus 10. So since we are minusing a value to get the next value, this is actually the arithmetic progression. So this is actually our D, and D would be negative 10. Negative because it is declining. Okay, so means for this situation, we can use the formulas in the arithmetic progression. Okay, so here let me use T1 as the sales in the first week. Alright, T2 would be the sales in the second week. So this pattern will continue until the 9th week. Okay, so it's until T9. So these 9 terms will follow this progression. Okay, and it says that because of a promotion, the sales increased 50% in the 10th week compared to sales in the previous week. So for T10, it increased 50%, so means the number of cakes sold in this week would be 1.5 times T9, right? Because here we have an increase of 50%, so we are going to use the value of T9, up it with 50%, so it's 1.5, right? So 1 here represents the number of sales in week 9, and the 0.5 here would be representing the increase of the sales, right? That's why here is 1.5. Okay, so it says here for each cake generates a profit or RM8. So now we need to find the total profit from the first week, which is T1, to the promotion week, which is T10. Okay, so to find the profit, let us find the total cakes sold first. Alright, so here this 9 weeks, the first 9 weeks, it is following this progression. So this is the first 9 terms. Then we are going to use S9 to help us calculate the total sales in the first 9 weeks. Okay, and then we are going to add the value of Tn, which is this one, 1.5 times T9. Okay, so now we are going to use the information that we have, substitute into the two formulas here to find the total cakes. So for S9, S9 will be 9 over 2, bracket 2 times A is 500, and N is 9, D is negative 10. Alright, and for next one is 1.5 times the value of A, which is 500, and here is 9, so it's 9 minus 1, and D here is negative 10, so here will be negative 10, and once we put this into calculator, we can find out our value is 4770 cakes. Alright, so now for each cake there's a profit of RM8, so the total profit would be this value multiplied with the RM8, and we will get the total profit. For question 5 focuses on system of linear equations, and in part A we need to find the value of x and y. So let's identify what is the values of x and y first. Okay, so values of x is the mass of block P, and y is the mass of block Q. Okay, so to find two unknowns we need two equations. So we are given one of the equations already, and now to find the second one, actually we can go into this first diagram, because as you can see it is balanced, right? So means the mass on the left side and the mass on the right side is the same, so we can form an equation from here. Okay, so here would be the mass of block P, which is x, plus the mass of block Q, which is y, plus 5 equals to 15. Okay, so this would be our second equation. So what we are going to do now is to use substitution, to use the more simpler equation and to substitute into the more complex equation. Okay, so I'm going to rearrange this equation, so move the 5 to the right side, and I'm going to move x to the other side. Okay, so y on the left side. So what I'm going to do is to substitute this into the first equation. Okay, then I simplify, then I can get n quadratic equation. So what I'm going to do is to factorize and using the calculator to find the two answers of x, okay, which is 15 and 8. And now I'm going to use back this equation to find the value of y. Right? So for x and y, they are the mass, and mass cannot be negative. So for this pair of answer, I am going to reject. Okay, so our value of x is 8 and our value of y is 2. Okay, so we can write a final conclusion somewhere here. And for part B, it says an additional block of 38 kg is put into this balance, and we need to find the number of blocks P and Q that needed to be added again to rebalance this scale. So if we assume that the number of blocks of P is 8 and the blocks of Q is B, so the total mass must equal to 28 kg. So let's form an equation on this. Alright, so let's find the total mass of the blocks according to the answers in part A. So here we have, for every block P is 8 kg, so 8 times A, and then we are going to add the value where the mass of block Q multiply with the blocks of Q, which is 2B, and they're going to equate it with 28. So what I'm going to do is I'm going to simplify this equation a bit. So divide 2 with the whole equation, then we can get this one. Okay, so to find the value of A and B, it can have a lot of answers, alright? But we need to make sure that the value of A and B is integers, not decimals, because here is the number of blocks, alright? And then we need to add up to 14. Okay, so here one of the answers is we can put A equals to 1. So here will be 4, and I move 4 to the other side, which is 14 minus 4, so B is 10. So means we need to have 1 block of P and 10 blocks of Q. Right? So this is just one of the answers. Okay, yours can be different from mine. So for example here, maybe I can put A equals to 2. Right? So for 2 will be 8, and 8 I move to the right side, so B here will be 6. So this is also an answer. Question 6 focuses on trigonometric functions, and in part A we need to prove this trigo equation. Alright, so in proving trigo equations, I would say that this question will be the hardest among all the trial papers. So later you'll see why. And the marks given here is too little. 2 marks is not enough, at least 3 is better. So that's why I said this paper is not really fair to the Sabah students, alright? But nevertheless, let's prove this equation, okay, together. So to start off, we are going to use the technique that we always use, which is to use the more complex side to prove the less complex side. Okay, so here the more complex side I would say is this part lah. Okay, so we're going to use the left side to prove the right side. Okay, so if we look at the sine and the cos, inside it there are 2 angles. So here we can use these formulas, right? The ones which has A plus minus B. So if we compare, value of A is theta, value of B is pi over 2, and we are going to substitute according to that way lah. Alright, so here will be sine theta cos pi over 2, and the symbol here is plus, so here I'm going to use a symbol on top which is plus also, and here will be cos theta sine pi over 2. Okay, so this is for the sine, and for the cos here same thing as well. So A would be theta, B would be pi over 2, so here is cos theta cos pi over 2, and this is plus, so I'm going to use the symbol on top. So please make sure, yeah, this is minus. Okay, this is minus, and here is sine theta sine pi over 2. Okay, so just to let you know, pi over 2 here is 90 degrees. Okay, so for the pi over 2 values here, you all can just use the calculator to find out the answer. Alright, so it will be something like this. So for those which have 0, we can just cancel off or ignore it. So once we simplify, it would be something like this. Okay, so now you see this is actually quite simplified. So how do we get to this? Alright, so this is the reason why I said this is the hardest, because this technique is quite rare to prove this equation, which is we are going to apply the conjugate. Alright, it is like we are solving the search questions, right? We need to apply a conjugate to remove the square root. So for this one, why we need to apply conjugate is because if you look at the numerator, it's just one thing, which is cos theta. But here, there is no fraction and there are two things. So we need to multiply something to have two things here. Okay, which is why we need to apply the conjugate. Alright, so here the conjugate would be the negative version of this. So it's 1 minus sine theta. Alright, so let's multiply the conjugate and this would be the result. Okay, so now we need to get rid of the denominator, right? Which is this one. So what we are going to do is we are going to find the formulas that has 1 and sine square theta, which is this one. Okay, so if we move this sine square theta to the other side, okay, let me change the a to theta, yeah, because now we're using theta. So now we have left with cos square theta. So this part would be just cos square theta. And now I'm going to use this value to divide with the two values here. Okay, so here would be, sorry, this one would be 1 over cos theta, and this one would be the cos theta cross off, so it's just sine and cos. Alright, so the inverse of cos is secant theta, and sine theta over cos theta is tan theta. Okay, so this is the way to prove the equation. Okay, so we have learned a new technique here. So once we have stuck something like this, and we need to have two things on top instead of one, we can multiply the conjugate. For next part, we need to sketch a cosine graph, and according to the range here. So 2 pi is actually 360 degrees lah. Okay, so now let us sketch a cosine graph first before we draw it into our answer sheet. Okay, this x and y axis graph. So I would recommend students to do this way also. We sketch a graph first and we change here and there, and once we are done, we are going to sketch it to our answer sheet. Okay, so the technique that I'll always use to sketch trigographs is to follow this sequence B, A, C. And what does this B, A, and C represent? Alright, so B will be the value of x, which is 3 over 2, and this value of B is the number of cycles that we need to draw within 360 degrees. So now value of B is 1.5. So I'm going to draw 1.5 of this cosine graph. Okay, so this is the first cycle, and the other half would be this, right? This half is only this half of the cosine graph. Okay, so here is 1.5 of the cosine graph. And now going to A. So A here is the minimum or the maximum value. Right, so now in the current graph, our middle line is the x-axis. So the middle value is 0. So means the maximum value is 1. And the minimum value here is minus 1. Right? So now with the minimum or maximum value, the value of A here is 2. So means for all the values here, we are going to multiply with 2. So here will be minus 2, here will still be 0, and this one will become 2. Alright, and for the value of C, C is actually the axis of symmetry, which is the middle line of the graph. So now it's minus 1, so means minus 1 here would be our middle line already. So it is not the x-axis anymore. Okay? So this also means for all the values here, we are going to minus 1 as well. So for the maximum value, I'm going to minus 1, so here it becomes 1. And for minus 2, here it will become minus 3. Alright? And there's another thing that we haven't dealt with, which is this modulus. Okay, why we haven't dealt with this yet? Because the values of A, B, and C are all inside the modulus. Okay, so we've dealt all of the things inside the modulus first, then only deal with it. Alright, so how do we deal with the modulus is we are going to move the parts which are below the x-axis to be above the x-axis. Okay, so now our x-axis is somewhere between 1 and minus 1, right? So x-axis would be somewhere here. So these are the parts which are below the x-axis, so I'm going to move it to the above. Alright, below of the x-axis to be above the x-axis, and this would be our graph. Okay, so we can draw it to our answer sheet here, and we are going to label the important y values. So here would be 1, and for this value, okay, let me go back a bit. Okay, just now it was negative 3. So with the modulus, it becomes positive, right? So the value negative 3 here will also become positive, right? So here will become 3. Alright, and then for the x values, I'm going to label the important ones. For example, the 2 pi here is the end point of the graph. But for pi, how do we know it is here? Why isn't here and why isn't the other side? Right, so let us go back and look at the original graph, which is this one. So here we have drawn 1.5 cycle of the cosine graph, right? So what I'm going to do is I'm going to split this graph by 3 parts, right? So just now in this part only, it's 1 cycle of the cosine graph, so I'm going to split them into 2. Okay, so it's something like this. So this part would be the first half of the cycle. Alright, this is the first part, and here I'm going to split in this way. So this will be the second part, and this will be the third part. So of course, for the middle point, it should be at the second part, right? And if we focus on this part of the line, you can see that the minimum point here, if I look at the original value, it's minus 1, right? This is the minimum value. And if I go to the top here, this is actually the maximum value, which is 1. So to find the middle, it should be the middle of these two values, which is 0. So now I'm going to find the part of the line that intersects this line, which is here. So this is actually our pi, the middle point of the entire graph. So once we apply modulus, this part of the graph will go up. So what I will do is just to look upwards to see where is the pi value now. So it would be on the y equals to 1 line. Alright, so when we are drawing the graph here, we are going to find the part of this part of the curve where it intersects the y equals to 1 line, which is here. Okay, that's why here is pi. And for the last part, we need to find the 3 solutions obtained if y equals to t is drawn onto the same graph, and we need to find the range of values of t. So what does this mean? Right, so y equals to t is actually just a horizontal line, okay, because t is just a value. Alright, so y equals a value would be a horizontal line, which is something like this. And 3 solutions. 3 solutions here means 3 intersection points. So meaning the intersection points of this horizontal line and our graph that we have drawn just now. So for example here, we have 1, 2, 3 points. So means 3 solutions, which can be our answer. Alright, so here it says range of values of t is because there will be a lot of t values that will satisfy this condition. So we need to put it into a range format. So for example, what value and what value? Sorry, t is between what value and what value. Okay? So now for each of the part in this graph, let us find the number of solutions or the number of intersection points. Okay, so I'm going to start off with the x-axis here. Okay, so if we see, we have 1, 2, 3 intersection points. So this can be our answer. Alright, okay, I think you all can see the tick. Okay, let me draw it here. Right, so this can be one of our answers. So let's go up a bit. Alright, so for this part, we have 1, 2, 3, 4, 5, 6. Okay, this is too much, so this is not our answer. And let's see when y equals to 1. Y equals to 1, we have 1, 2, 3, 4, and 5. Okay, so this is not one of the answers also. Okay, this one we have seen and it's our answer. For y equals to 3, it's only 1, 2, so this is not our answer. Okay, so if we look at this line, if we go up a bit, for example, if I draw here, oops, sorry, it's a bit not straight, but you can see that the number of intersection points is also 3, 1, 2, and 3. And below, it's also 3 points, 1, 2, and 3. So all of the values here are all our answers. Okay, so this is the range that we're talking about. So our answer would be from 1 until 3. Okay, so for answers, it would be t equals to 0. Okay, don't forget this. And also from 1 to 3. So here we need to put lesser than, not lesser than and equal to. Okay, don't put this one because 1 and 3 is not our answers, so we cannot include them. Alright, so here should be putting less than. And for the answer scheme, they only put this one, which I'm not sure why they didn't put this one. Maybe it's because the answer tells us to find the range of values. So this is the range. This is just stating the value, so the answer will be this lah. But I think to be safe, I think need to write out this one. Okay, the t equals to 0, even though it's not the range of values of t, but it's still a potential answer, right? As you see here, 1, 2, 3 points. Okay? And for question 7 focuses on differentiation, and here we have a cone-shaped water tank with these measurements here. So if I take out this part of the cone and if I draw it here, the radius of it is xcm, the height would be 1.5x cm. And it is also given that the water is filled into this water tank as well, so this water is also in a cone shape. Alright, so with a depth of hcm and the radius of r. So in part A, we need to show that the volume of the water is this result. Okay, so just now we have mentioned that this water is cone shaped, so to find the volume of the water, we can use the formula of the volume of the cone, alright, which is 1 over 3 pi r square h. But if you compare these two equations, you will see that here there's no r. So means we need to change this r to be in terms of h. Because if you see, there is h cubed here, but we only have one h here. Alright, so how do we change r to h? So the only clues that we have is just the measurements of the water tank and the water. But if you realize, these two things actually have the same shape, right? Which is cone shaped. So what we are going to do is we are going to compare the radiuses for both of the cones here, okay, the r and the x, and both of their heights, h and 1.5x. So with these measurements, we are going to form an equation to find the expression of r in terms of h. Okay, so to find this equation, what we are going to do is, so for the numerator, I'm going to compare their radiuses. So for r, I'm going to put it here, and for x, I'm going to put it on the right side. Okay, and for the bottom, I'm going to do the same thing. It's just I'm comparing the heights. So the part below r, I'm going to put h, and the part below x, I'm going to put 1.5x. So if you see, if I simplify this equation, x will cancel off, h will move to the right side, so we can find the expression of r in terms of h already. So with this, we are going to substitute this into here, the r part, and square it, then we can find the expression which we are required to show. For part B, we need to find the percentage change of the volume of the water, which is V, if the depth of the water decreases from 9 to 8.97 cm. So depth of the water is H. So now recall back, the formulas that we can use to find percentage change is these two formulas. So for the first one, I would say it's easy to memorize, but for the second one, I don't want y'all to memorize, I want y'all to understand the formula. Okay, so delta y here actually is the small change of y. Okay, so small change meaning how much did the y change. Okay, and for the y at the bottom, it's the original value of y. So this means, based on the original value, how much did it change? So to find the percentage change, it will be small change divided with the original value and multiply 100%. Okay, so this is how we find the percentage change. So now we need to find the percentage change of V. So for all the y's here, I'm going to change it to V. Okay, so again, we need to find two things. One is the small change of V, and the other one is the original value of V. So to find the first one, which is delta V, we can use this formula. Alright, and for the x here, I'm going to change it to h because we have an equation which relates V and h. Okay, so there's a relationship between these two unknowns. Okay, so now if I want to find delta V, I'm going to move delta h to the other side, and now I need to find these two things. Okay, so for dv over dh, we can find it by differentiating this equation. Okay, so the power here, I am going to multiply with the value here, so it's 4 over 27 pi. So I'm going to multiply with 3, so here will become 4 over 9 pi. Okay, pi will be following this value because pi itself is a value, it's not an unknown. Okay, so we don't have to differentiate this pi. Alright, and for the power here, I'm going to minus 1, so here will be 2. Alright, and for the small change of h, actually in the question, they already gave us the change, which is from 9 to 8.97 cm. So to find this delta h, very easy, just find the differences between these two. Alright, so we can find the small change in h, which is negative 0.03. So why is it negative? It's because it is decreasing. Okay, so decreasing, usually we need to put negative at the front. Alright, and then another thing, here the only thing which is not in value is this h. Okay, this h, we are going to substitute its original value. Alright, which is highlighted in orange here. This is the original value of h. Right? Because it changes from 9 to this value. So this h, I'm going to substitute with 9. But for the value of h here, why didn't we use 8.97? Because this is also another value of h. But this value of h is the changed value of h, which is after the experiment. So if you want to find the change of the volume of the water, it will be best that the factors, like for example h, don't change. Otherwise, it will affect the accuracy of finding the change in volume of the water. We will remain everything as the original values. And then we can find the value of delta V. Alright, so I'm going to put it here. And for the original value of V, okay, this one very straightforward because we have the original value of H already. So we are going to substitute this value inside here and we can find the original value of V, okay, which is 108 pi. So if I calculate this, then we can get the percentage change. So this means that the volume of water decreases by just 1%. And here we write decreases because the percentage change is negative. And for part C, we are given the surface area of the water which decreases at this rate. So surface of the water, let us assume that it is A. So if you want to describe the rate of change of something, in differentiation, we are going to put dt at the bottom. Okay, so the rate of change of A would be dA over dt. Alright, and here it says decreases, so means we need to put the negative in front. Alright, decrease, need to put negative in front. So now we need to find the rate of change of the volume. So this one would be dV over dt. Again, for rates of change at the bottom, we need to put dt. Okay, and it says that when the depth of the water is 9 cm, so depth is h. Alright, so to find rate of change, what we are going to do, we can use these 4 steps. Alright, so this is known as the 2SF method. Alright, the first 2 steps start with S, the last 2 steps start with F. Okay, so for the first one, we have already found, which is the rate of change that we need to search, which is dV over dt. The second step is to split the fraction. So for dV, I'm going to put in the first fraction, dt, I'm going to put in the second fraction. Okay, and the third step is to fill in the blanks. So we are going to find the unknown which relates with V, which in part A and part B we are keep on using this relationship, right? So we are going to put H. Okay, so now for the fourth step, we are going to find the 2 values of these 2 fractions. Okay, so for this one, usually we need to differentiate, and actually in part B we have already found this, okay, which is this one. So we are just going to substitute this inside here. Right, but the value of H here, same as part B, I am going to substitute its original value, which is 9. So for the H here, I'm going to substitute 9. Alright? And here for this one, it is usually given. So this dH over dt is given in the question, but sometimes they might be indirectly give you the value. Okay, so this one is indirectly lah. So what we can do, right, is we can use the same steps as here for dA over dt. So this means for dA over dt, when I split it out, I need to include the dH over dt here. So this means here I need to put dH. Okay, so now to find dH over dt, we need to find out these 2 values. Okay, so for this one it is given, so we don't need to do anything. But for this one, we need to do something. Alright, because this one, if you want to get it, we need to differentiate first. But we don't even have the surface area formula yet. So let's find out it now. Okay, so as we know the shape of the water currently is in the cone shape, right? So the surface of the water is here, which is actually a circle. So to find the surface area, we are just going to find the area of the circle, which is pi r square. But as you see here, it must have a relationship of a and h. So we need to change this r into h, which we can use the information in part A just now, which is this one. Okay, remember the triangle? So this is the relationship that we got just now. So for r, I'm going to substitute this value inside. Okay, so this will be the result. And now here is dA over dH, so I need to differentiate this equation. Alright, so the power will be multiplied with the value here, 4 over 9 pi. So here will become 8 over 9 pi. And the power of h here, I'm going to minus 1. So here will be left with h. Okay, so now I'm going to substitute this value inside here and find the value of dH over dt. And another thing to let you all know, this value also needs to be substituted with the original value of h, which is 9. Okay, otherwise you cannot find the value of dH over dt. Alright, so once we rearrange, then we can find the value, which is negative 25 over 8. So I'm going to substitute here and find the value of the rate of change of v, which is this one. Okay, so for the pi, please make sure to change it to 3.142 because the question here says in terms of pi. So now we are going into section B, and the first question comes from vectors. So here there's a lot of information, so let me help you all summarize it using this diagram. Okay, so here we are given a parallelogram, which is PQRS. So the lines PS and lines QR, they are parallel to each other, and another pair of parallel lines would be lines PQ and lines SR. Okay, and here it says that S is the midpoint of this line, so means the lines PS and lines ST are the same length. Okay, so means their vectors could be the same as well. So now they give us the vector of ST, so means that these two vectors would be A as well. And they also gave us the vector PQ, so since this is 2B, here is also 2B. And then they also gave us a ratio, so I'm going to move this PQ to the other side. So now I can clearly compare. So TU is 3 parts, PQ is 2 parts. So if 2 parts is 2B, so means 1 part is B, so means 3 parts is 3B. Okay, so the vector of TU would be 3B. And now what I'm going to do is to highlight all the lines that has vectors. Right, so it will be easy for us to find the other vectors, for example in part A. Okay, because these lines already have vectors. So for part A1, if you want to find PU, so we need to set our route first. So P is here and U is here. So what we can do is we pass through P to S and to T. Okay, so our route here can be P to T, and then from T go to U. Alright, so the vector PT would be A plus A, so it's 2A, and TU is 3B. So this will be our vector for PU. And for QU, so now we are going from Q, which is here. So now we are going to pass through, we are going to P. And then we are going to the same route as part A1. So means for the route here, I'm going to put QP. And since in part 1 we already found the vector of PU, so I'm going to use back the vector in part 1. Okay, so I'm going to put plus PU here. Right, because we don't want to do the same thing twice. Alright, so here QP would be going into the opposite direction from the given vector here. So for opposite directions, we need to put negative. Alright, so here it's negative 2b, and we are going to put the answer in part 1 here and simplify. Then we can get the vector QU. And for part B, we need to determine whether these 3 points are collinear or not. So recall back, collinear means that these 3 points are on the same line or not. Alright, so another word for collinear is actually parallel. So why is collinear parallel? Because, okay, let's say for this line PU, I split them into 2 lines, PR and RU. But if I split out, this means these 2 lines, they are actually parallel to each other, right? Because they are from the same line. Okay, which is why they are parallel to each other, which is why collinear is another word for parallel. Alright, so since this is parallel, we can use this information to help us on this question. Alright, so this equation means that if we have a vector of one of the parallel lines, okay, so we just need to multiply a value. So this is called lambda, Lambda. So if I multiply it, I can find the vector of the other parallel line. Alright, so to use this, we need to have 2 vectors from this line first. Okay, so we already found one of it in part A, which is actually PU. Okay, because the 2 points here are actually within these 3 points. Okay, so we need to find another one. Let's say we find PR. Okay, so now let's find the route from P to R. Okay, so there are 2 routes actually, so I just choose one of the routes. So I can go from P to Q, okay, and then Q to R. So this will be my route, P to Q, Q to R. So P to Q is 2B, Q to R is A. Okay, and now what I'm going to do is, now we have these 2 vectors, we are going to substitute inside this equation. Okay, so it will be something like this. So now, to prove whether these 2 vectors are parallel or collinear or not, we need to find the value of lambda. So to find this value of lambda, we need to compare the values that has vector A and at the same time compare the values that has vector B. Okay, so there will be 2 sets of answers. So here I am going to compare the value of vector A here, which is 1, with 2 lambda here, right? And for vector B, I'm going to compare 2 with 3 lambda. So if you calculate these 2 lambdas, you can see that they are actually not the same. So what does this mean? Hey, this means that the points PRU are actually not parallel. Okay, so we can write out a conclusion here. So since both of the lambda values are not the same, so PRU are not collinear. But you may ask, why lambda values, if it's not the same, means they are not collinear? So if we substitute these 2 values back into this equation, right? So let's say CD is this vector, and if we multiply 1 over 2, the vector AB will be half of vector CD, so it will be something like this. And if we substitute the value 2 over 3 into the lambda, the vector AB would be something like this. So one is shorter and one is longer. So which is the true vector AB? This one or this one? The answer is, we don't know, because the lambda values are both different and we are comparing the same vectors here. So if there are 2 lambda values, we will produce 2 different vectors, which means these 2 vectors cannot be put into this equation, which is why they are not parallel, not collinear. That's why here we say lambda values are different, means that they are not collinear, because these 2 vectors cannot be put into this equation at all. And for part C, we are given the values of vector A and vector B, and we are given the unit vector for QU. So now we need to find the values of M, N. So M is here and N is the values of vector A and B. Okay, so now to do this, since they already gave us the unit vector for QU, why not we find out ourselves the unit of QU as well? Okay, so QU is one of the vectors that we have found in part A, so I'm going to use that answer to use it here. Okay, so for the A and B here, I'm going to substitute it with the values given. Okay, so we simplify, it will be something like this, and now I'm going to use the unit vector formula to find its unit vector. So very simple, use the vector divide with its magnitude. So magnitude means the length of the vector. Alright, so the value of x here will be -4 and the value of y will be -n. Right, so we are going to put the vector here and then we are going to find out the magnitude. So value of x is -4 and the value of y is -n. So we square them, add it up together and then square root. So now if you compare the unit vector given in the question, you can see that the numerator value is different. Alright, so if you want to compare, we need to make sure the values are the same. So what we are going to do to make sure this is 2, we are going to factorize or take out 2 from this bracket. Okay, so it means that the values inside this bracket will divide with 2 to put 2 here. So you can see the values here are now the same, and also you can see the value of vector I is the same as well. So now we can truly compare. Alright, so let us find the differences between these two. So the first difference is the value of j, and the second difference is the value inside the square root. Okay, so for the things highlighted in green, you can see that there is m and n, but for the red one there's only n. So for this one, we can find the value of n straight away, which is -4. Alright, so with the value of n being found, then I can write an equation by comparing these two values, substitute the value of n, then I can get the value of m, which is 32. For question 9, focuses on probability distributions, and for part A, we are focusing on binomial distributions. Alright, so we have the number of trials, which is A, and the probability of success, which is B. So now in part 1, we need to find the mean and the variance, and we need to express it in terms of A and B. Right? So recall back the formulas for binomial distribution. So for a mean, it will be n multiplied with p. So n is the number of trials, which is A, and p is the probability of success, which is B. Okay, so for the mean, very simple, it's just A times B. And for the variance, so this one is a standard deviation, so we don't need to put the square root, but here it would just be n times p times q. So n and p is A and B, and q is the probability of failure, so here we need to use b, which is 1 minus b as the value of q. And for part 2, we are given that A is equals to 10 and B equals to 0.85. So now we need to find the probability where x equals to 7. So here we are going to use this formula to help us. Alright, so the value of r here would be 7, and for the first part here, it's NCR, so n is the value of A, which is 10, and r would be 7. And p here would be the value of b, which is 0.85, and the power would be r, which is 7, and the probability of failure, which is q. So to find this, I'm going to use 1 minus 0.85. Alright, and the power here will be n minus r, so it's 10 minus 7. So once we put this into the calculator, we can get the probability, which is 0.1298. And for part B, we are focusing on normal distributions, as you see here. So here it says the marks of the students are normally distributed, so we are going to put x as the marks of the student, and for the value of x, it follows the normal distribution with mean 150 and standard deviation of 10. Alright, so in part 1 it says that among 500 students, 350 students are successful in this application. Alright, so they want us to estimate the minimum score for the students to be successfully in this application. Right, so let me put a minimum score as x first. Alright, so to solve any kind of normal distribution question, we are going to use the 5S method to help us. Right, so the first S is to write out our statement, the probability statement. So for this statement, we need to figure out by ourselves because it's not given here directly. So for our probability statement, it needs to relate with the minimum score. So means our probability can be formed in a way that we focus on the probability that the student is successful. Right? So for a student to be successful, the marks of the student, or the big X here, must be greater than the minimum score, right, or the X. So for the probability, we can aim it in this way. We will find the probability where big X is greater than X. Because if it's greater, then means that student is successful, right? So we're going to find this probability. So to find the probability where the student is successful, it is actually given here, right? Because among 500 students, 350 are successful. So we are going to find the probability according to these two values. So 350 divided by 500, then we can get the probability of success. Right? So this would be our probability statement. So to recap, how do we get this probability statement is, okay, so I will split into two parts to explain this. So the first part on the left side is to set this probability statement, we need to relate it to the minimum score, right? And usually for students who achieve this minimum score, they are successful. So the probability that we have selected is the probability where the student is successful, right? So for the student to be successful, the marks of the student must be greater than the minimum score, right? So which is why on the left side, we will put this statement where we are finding the probability where the big X is greater than small x. Okay, because we want to find the probability where the student is successful. Okay, so to find the value of that probability, which is the second part, we need to use the data here, right? Because here it says 500 students, 350 of them are successful. So this is the successful rate actually. So we are going to divide it and find the probability of success. Okay, so this is how we form the probability statement. Alright, so for the second S is to search our parameters, which we have already done. The third S is to standardize. So standardize meaning I'm going to change X to Z. So X is the normal distribution, Z is the standard normal distribution. Alright, so we are going to use this formula. So X minus the mean divided with the standard deviation. So X here is the small x, right? Mu is 150, standard deviation is 10. Okay, and then we can go to the fourth step, it is to sketch. We are going to use this statement to sketch out the standard normal distribution graph. Alright, so this one, okay, let's look at the sign here. So this is the greater than sign, so means it is like an arrow that is trying to tell us to go to the right side. So here, when we are sketching the area, we are going to sketch to the right side. Okay, and the probability here is 0.7, so we know that half of the graph is 0.5. So when we sketch the area, it must involve two sides, left and right. Okay, so we can assume that this value would be on the left side of the graph, because later on we are going to sketch it to the right side, and when we sketch, we need to sketch more than half of the graph. So the value of z here would be somewhere on the left side. So if this value is here, so we can sketch it to the right side, and this would be our graph. Okay, so now for the fifth S is to select. So select means we are going to select the values in the normal distribution table that we are going to see later according to our graph here. But our area here, we need to satisfy these two criteria. So the first criteria is the area must be one-sided, which we have already failed, because as you see, the area here, it involves two sides. Okay, and the second criteria here is from the right side. Okay, from the right side means that this area is connected from the right end of the graph. So means I can sketch it from the right side. Okay, so this one is satisfied, but this one it failed. So how can we solve this? Alright, so instead of focusing on this area, we are going to focus on the other area which is not our focus, which is here. Right, so why I focus on this is because it is one-sided, but it fails this criteria because it's not from the right side, not from the right end, it's from the left end. So what we are going to do is, since the standard normal distribution graph is symmetric, meaning left side and right side, they have the same shape, so I am going to move this green color area here to the other side of the graph. Okay, this wouldn't affect anything because the shape is the same, because it's symmetric, left side, right side have the same shape. So same shape means same area, and same area means same probability. But the only thing that I need to change is this z value here. Okay, so this value is actually negative because it's on the left side of the y-axis here. So when we move it to the other side, this value will need to add with a negative. Okay, this is not negative value here because this value is already negative, so negative, negative, positive. So this will be a positive value, and later I will show you all the value. Okay, so now since we are moving to the other area, so we need to write out another probability statement here. Okay, so for this area, it is like sketching to the right side, so means I am going to use greater than here. So this is the probability where z is greater than this value. Okay, and since we are changing to another area, okay, so previously this was 0.7, so to find the area of this green shape, we are going to find the area for the entire graph, which is 1, right? And then minus off with the area for this orange part. So 1 minus 0.7 is 0.3. So this area is 0.3. Okay, so now as you can see, this shape has satisfied these two criteria, and now we can go to the tables to find out the z value according to this probability. So to find the value of z, the first step is to find the first value which is larger than 0.3. Okay, so if you look at here, the first value which is larger than 0.3 is this one, 0.3015, because as you can see, the next value is lesser than this value already. Alright, so now the second step is to minus, meaning find the difference between these two values. So here it's 15. So meaning from the same row, we are going to find the value of 15. Okay, but it's not here. So if it's not here, what we need to do is to find the closest value to 15. Okay, so in this case it's 14. Okay, so since there's no 15, we can just minus with 14 lah. Okay, even though there's a difference, but the difference is small, so it's okay. Alright, so now once we have find our two values here, we can find our z values by looking at the sections A, B, and C. Okay, so for section A, our value will be 0.5. For section B is 2. For section C is 4. So our z value would be 0.524. So according to the table, the z value is 0.524. So we can equate with these two values. Okay, so now you can see that this value that I've mentioned is a positive value. Alright, which is this value 0.524. So now to find the value of z, you can just simplify this equation lah. So you will get 144.76. So the minimum score for students to be successful is this value. For the second part, it says that the mean score has to be changed and the standard deviation maintained. So means this 150 we need to cancel off first. Alright, why it needs to change? Because it wants 90% of the students to be successful. Okay, so this is the probability of success, which is 0.9. Okay, and it says, oh, it also gives us the minimum score of the student to be successful, which is 120 marks. So this time we need to find the mean value. Okay, so again we are going to use the 5S method, and the first S is to write out our probability statement. So we are going to use the same technique in part 1. We are going to focus on the probability that the student is successful. So for a student to be successful in this case, the marks of the student must be more than this mark given here. So our probability would be x is greater than 120. Alright, and the probability of it would be this one, 90%, because they want 90% of the students to be successful. Okay, so the probability here we will put 0.9. Alright, so now go to the second S, which is to search our parameters. Okay, so for this mean we don't have already, so let us use mu at this moment. Okay, mu is the symbol for mean. Okay, so the standard deviation no change, which is 10. So now go to the third S, which is to standardize. So we are going to use back the formula, which is z equals to x minus mu divided with sigma. So here will be 120 minus mu divided with the standard deviation, which is 10. And the fourth S is to sketch, so meaning from this probability statement here, we are going to sketch out our area using this standard normal distribution graph. Alright, so this area that I'm going to sketch later is very similar to part 1. Because we have the greater than sign, which means we are sketching it to the right side, and the value here is more than 0.5, which means we are going to sketch more than half of the graph. Alright, so because this value is even larger, so the value of z here would be much to the left. Okay, so it's somewhere here. So now we are going to sketch it from here to the right side, and this would be our sketched region for our area. And now going to the fifth S is to select the value from the normal distribution table, but our region to satisfy these two criteria. So similar as part 1, we have failed the first criteria, achieved the second criteria. So what we did was we focused on the area that is not highlighted here, and then we moved it to the right side because the curve here, the graph here is symmetric. Left side and right side have the same shape. Same shape means same area means same probability. Okay, so the only thing that we need to change is the value of z here. So it's negative because it's on the left hand side of the y-axis here. So move it here, we need to add a negative. Right? So negative value with negative becomes positive. So this is a positive value. So now we need to write out the probability statement according to here. So similar to part 1 as well, this is sketched to the right side, so it's greater than sign. So here will be probability where z is greater than this value. Alright, and then to find this area, also similar to part 1, it will be 1 minus the area here, which is 0.9. Okay, so it will be 0.1. Alright, so now the green area satisfied both criteria, then we can go to the tables to find out the z value. And now to find the value of z, the first step as usual, we are going to find the first value which is larger than 0.1. Okay, so according to this table, it is this value, right? 0.1003. Okay, as you can see, the next value is lesser than this value. Okay, so now the second step is to find the difference between these two. So the difference is 3. And now we are going to look at the same row and find the value of 3. So here there is no 3. So now we find the value which is closest to 3. But here we have two values which is equally close to 3, which is 2 and 4. So which one should we choose? Alright, so for this case, it's a special case, meaning both of the values would be accepted as answers. Okay, because both of them are equally close to 3. Okay, so for our case, I would select 2 lah. Alright, so we have found our two values, and now to find the value of z, we can match it back to the values in section A, B and C. So for section A, it would be 1.2, section B would be 8, section C would be 1. So our z value would be 1.281. So another answer for this case, it would be 1.282 if you select the value of 4 here. Alright, so from the table, the z value is 1.281. So we are going to compare the z values here. So again, this value is positive. And now we can find the value of the mean, which is 132.81. Next question focuses on integration. So here we have a curve and a straight line, and in part A we need to find the coordinates of point A. So as you see, this point is actually the intersection point of the curve and the straight line. So what we are going to do is to use the substitution method to find the coordinates, right? So means I'm going to substitute this equation to the other equation and to find the coordinates. So for the y, I'm going to change it to 2 over x squared, and I'm going to move the x squared to the other side, so here will be x cubed. And then for the cube here, I'm going to move it to the right side and find the value of x, which is 2. Alright, so now I'm going to substitute back into this equation to find the value of y. So the value of y is 1 over 2, and our coordinates would be 2, 1 over 2. And allow me to label the coordinates of A in this diagram. Okay, so 2 I'm going to label on the x-axis and 1 over 2 label at the y-axis, because these two numbers would be very useful for us when we are calculating the answers in part B and part C. So for part B, we need to find the area of the shaded region, which is shown here. Okay, so to do so, we are going to use the method that we always use, which is big shape minus the small shape. Alright, so big shape would be the recognizable shapes that includes the shaded region. But for this question, it will be a bit hard for us to just use one shape to include the entire region here. So what I'm going to do here is a bit special. I'm going to use two shapes for our big shape. Okay, so for the big shape, the first shape would be this rectangle. Alright, so I'll label this as area A, and for the other area here, it's the area under this curve, which is also area bounded by this curve. Right? So I'll label this area as area B. Okay, so these two would be our big shapes. And now, once we use these two big shapes, you will see that we accidentally included this white color part here. So these are the small shapes, the shapes where we need to remove from our big shape. Okay, so here our small shape is the triangle. Alright, so to find the area of shaded region, we are going to add up these two areas and minus out the area of triangle or area C. Okay, so now we are going to use their respective formulas to find out the area. Alright, so for area A, this is a rectangle, so we are just going to find the length, which is 32. And for the width, okay, for the width, we don't really know the x coordinate of this point, okay, because we need to find the width here, so we need to figure out the x coordinate. So we are lucky because here we have the y coordinate already, so we are going to substitute it here. Right, so the y here will be 32, and we move x squared to the left side and move square to the other side. Right, so this one, it would be square root 1 over 16 plus minus, but here I will just use the positive value only. Reason is because this point is at the right side of the y-axis, so naturally all the values of x here are positive. That's why I just use the positive value. So negative 1 I can just ignore. Alright, so for the width here would be 1 over 4. And for area B is the area under the curve. So for areas under the curve, we need to use integration. Alright, and using integration, there are two ways. So either using the x-axis way or the y-axis way. Right, so to determine which one to use, let me go back a bit and let's look at the area B. Okay, so if you see here, this area is actually bounded by the x-axis, or meaning it touches the x-axis. You can see that it doesn't touch the y-axis. So what we are going to do is we are going to use the x-axis since it touches the x-axis. Alright, so if you are using this one, means x is on the outside and y is in the inside. Okay, so for the y, it would be the equation of the curve, which is this one. Right, so allow me to move the x squared to the above, right, because it would be easier for us to integrate later. Okay, and since we are looking at the x-axis, so we are going to find the lowest and the highest value of x to put in our range. Alright, so the lowest x value will be 1 over 4, the highest x value will be 2. Okay, and for area C, so area C is the triangle, and we are going to use the formula of the area of triangle, which is 1 over 2 times the base, okay, which is here, so it's 2, and the height, which is here, which is 1 over 2. So now we are going to simplify this. Alright, so for the integration part, we're just going to use the normal integration way. So the power, I add 1 and I'm going to divide with the new power. So negative 2 plus 1 is minus 1. Alright, so it will be something like this, and the range, I'm going to put it at the end of the bracket. Okay, so now I'm going to substitute the two values into this bracket and find out its difference. So it will be something like this. So once we put this into the calculator, you will get the final result, which is 14 and 1 over 2 units squared. And for part C, we need to find the volume generated in terms of pi. So this means the pi don't change to 3.142, remain it as it is. Alright, if the same region rotates around the x-axis at 270 degrees. Alright, so to find volume, usually I will take a step back. Instead of finding volume, I find the area of the shaded region P first, which we have already done in part B. right? We identified these three areas and then we found the area. So why I say I focus on the area first, because I want to identify the shapes that help me to find the volume, right? So what I require to find the volume is the shapes first, right? The area of the shapes that we are about to rotate later. Okay, so the shapes here are very important. So now, to find the volume, so we are going to use back the same method in part B, which is we are going to find the volume of these two areas first, which is A and B, and add them up together, and I'm going to minus out with the volume generated from area C. Okay, so it's similar to part B. And here we are not rotating one cycle, right? Because one cycle is 360. So here we need to multiply a ratio lah. So here will be 270 divided with 360. So here will be 3 over 4. But before we find the volume, I just want to share some knowledge. So when we rotate 2D shapes that we know of around the X or the Y axis, we would form 3D shapes that we know of as well. So in SPM, it would be these two examples. So if our 2D shape is a triangle, if we rotate around the X or the Y axis, our 3D shape would be a cone. Okay, and if our 2D shape is a rectangle, if we rotate around the X or the Y axis, it will produce a cylinder. So if our areas are triangle or rectangle, if you want to find the volume, we can use the volume of the cone and the volume of the cylinder's formula to find out the volume generated. Okay, so for example, for volume A, as you see for area A, it is a rectangle. So to find the volume A, we are going to use the formula for volume of cylinder, which is pi r square h. So we are going to start off with pi first, and for the radius, it would be from the x-axis here to the top, right, which is this line. So from the 2D shape here, it would be from the x-axis to the line. So from the diagram here, it would be from the x-axis towards this line. Okay, and the length of this line is 32. And we're going to put a square here. And for the height, so height would be the length of this line. So for a 2D shape, it will be the length of this line. So for the diagram here, it will be the length of this line, which is 1 over 4. Okay, and for volume B, so for area B is the area under the curve, and if we want to find the volume with the area under the curve, we are going to use integration also. Alright, so in the question here, it says rotate around the x-axis, so we are going to use the x-axis way. Okay, so please remember to put pi in the front first. Alright, and since we are using the x-axis, so x is on the outside, y on the inside. Alright, but for the y here, it is y square. Okay, so here our equation is just y, so what we need to do is to square both sides to get the expression of y square, which is this one. Okay, and similar to part B, we are going to move this to the top first because it's easier to integrate. And since we are looking at the x-axis, so we are going to find the lowest and the highest x value according to area B, which is similar to part B as well, which is 1 over 4 and 2. And lastly, for volume C, so area C is a triangle, and if we rotate the triangle around the x-axis, it will produce a cone. Alright, so we can use the formula for cone, which is 1 over 3 pi r square h. Right, so we're going to start off with negative 1 over 3 pi. And for the r, the radius here will be from the x-axis to the top here. So it will be the length of this line according to this 2D shape. So according to the diagram, it will be the length of this line, which is 1/2. And we are going to square it. And for the height, it would be the length of this line. So for the 2D shape here, it will be the length of this line. So for the diagram, it will be the length of this line, which is 2. Okay, so now we can simplify the entire expression here. So for this one, we are just going to integrate using the regular way. So power, I add 1, and I'm going to divide with the new power, which is -4 plus 1, which is -3. Alright, and I'm going to put the range of values of x on the end of the bracket here. And then what I'm going to do is to substitute the two values inside this bracket and find the difference. Okay, which is here. Here. And once we simplify everything, then we can get the volume generated, which is 255 and 3/4 pi units cubed. But before we go to the next question, I think that some students, they may question for part B, which is this the only way that we can find the area of shaded region? Well, technically no, because in part B we use the x-axis way. The other way is actually using the y-axis way, right? So let me show y'all. So I'm going to use back the same technique, which is big shape minus a small shape. And for big shape, I'm going to use two shapes. Again, one shape cannot include the entire shaded region here, right? So for the two shapes, the first shape would be the area under the curve here. And I'm going to split it using this line. Y equals to 1/2. So the first area would be this one. And you will see that this area actually touches the y-axis. So we can use this way to find out the area. Right? So this is for the first area. The second area is actually shown here. The shape is already shown, which is the triangle. Right? So these will be our two big shapes. And for the small shape, because for these two areas we have already included the entire region P, and there are no white shapes, so there's no small shape in this case. So the way to find out the area, it will be area A plus area B. But I would not recommend to use the y-axis way for this question because of part C. As you know, in part C, we are rotating around the x-axis. And to find volumes, I will need to find out the shapes first, right? Using the area of shaded region. So imagine if part B we have these shapes, and in part C we need to find out different shapes to solve the question. So why not, to save the time, for B and C we are all going to use the x-axis way. So the areas or the shapes will be the same for B and C. Okay, so this is one of the ways that we can save our time when solving these questions. By looking at all of the questions first to see we are rotating around the x or the y axis, and then we use that axis to solve all the questions for areas and for volumes. Alright, last question in section B. So here we have this nonlinear equation and we have the set of values of x and y. So in part A, we need to construct a table and find out the values of ln y. Right, so ln here is basically log base e y. Right, you will see this ln in your calculator. Alright, so to find the ln y, we just substitute the values of y here inside here to get the set of values, right, which are these. Okay, so put it in two decimal places. And now for part B, we need to, based on the scales here, to draw the best fit line. So what we need to have is the set of values for x and ln y lah, right, to plot the points. And before we go to the whiteboard to draw the graph, I just want to let you know in part D, there will be one value which is incorrectly recorded. So when we plot the points, right, there will be one point which is very far away from our best fit line. Okay, so now let's go to the whiteboard to draw the best fit line. So for part B, we are given the scales here. So here it says 2 cm to 1 unit on the x-axis. So 2 cm means one big box. So one big box, 1 unit. And for the rest of the values here, I'm just going to add 1. And for the lon y-axis, right? So for this axis is 2 cm to 0.5 units. So for one big box, 0.5 units. And for the rest of the values, I'm just going to add 0.5. And those are below, we would minus 0.5. So I would say this question is also quite sneaky in a way. There are negative values if you look at the lon y values here. So we need to provide space for negative values, but how big of a space is sufficient? Right? How much space should we provide for the negative values? So this one, we need to look at the highest lon y value, and according to this value, we need to label the last lon y value, which is larger than this number, but it is close to it. So meaning, we don't put the last value, which is, let's say, 4. Okay, because if here is 4, means here is 3.5, right? And 3.5 to 4, there is no points between this range, right? So I would say this space is, I would say, wasted. And this space will be useful if we put into the negative part here. Because maybe the y-intercept, right, that we are going to obtain later, maybe it's below, very below the negative values. Maybe it's negative 1.5. So if you imagine we didn't draw this out, then we need to rub the entire graph again and then draw back. So it would waste a lot of time. Okay, so before drawing, look at the lon y values first. Look at the highest of them, and then when we label the last value here, make sure it is larger but close to it. And for the labels of the x and the y axis, make sure it's x, and here it's lon y. It's not y, it's lon y. So if it's y, it will be deducted marks. Okay, so please be careful. So now with the correct scale of both of the axes, then we can use these points to plot the points here, as you see here. Alright, and now we are going to draw our best fit line. So let me drag this graph to the middle. Okay, zoom in a bit. Alright, so to draw best fit lines, we have two rules. The first rule is to pass through as many points as possible. Okay, so here needs to have a little bit of trial and error lah. Okay, so I need to move the ruler here and there, and then to see how many points that I can intersect. Alright, so here if I move into this way, okay, in this way, we can only intersect 1, 2, 3, 4 points. Okay, so this one, it touches a bit, but it's not intersecting this point. So this point is not counted. So here we intersected the second, the fourth, the fifth, and the sixth point. Right? So 4 out of 6 is good. So the points which are not intersected will follow the second rule, which is the points above and below the line must be balanced. So this is an example of balance. So as you can see here, there is one point which is above the line, and one point here, I hope you can see it, is below the line. So this is called balance. So unbalanced means that we have 3 points above the line but 0 points below the line. Okay, so this is unbalanced, and for unbalanced cases, the best fit line will not be a good one. Alright, so now let's draw our best fit line, and let's make sure to intersect the y-axis. Okay, because in part C, we would be finding the y-intercept later, right? So let's find it now. Okay, so according to here, so one small box, right? So here, if I look at from negative 1.0 to negative 1.5, we have 10 boxes, alright? 10 small boxes. So the difference between these two is 0.5. So means that for one small box here, it's 0.05. Okay? So now, if I want to go up to here, it's negative 1.5 minus 0.05. So it's negative 1.45 here. And I go up again. So I minus another 0.05. So here it's negative 1.4. Okay, so our y-intercept is negative 1.4. So now let's go back and to solve the questions for part C. But before going to part C, I just want to explain this point. Okay, so as you see this point, right, it is very far away from the line. So this is the incorrect point that I have mentioned to you all just now. Okay, so this one is normal, it's alright, right? Don't have to worry about this point. So for part C, we need to find the value of n and m. But the issue is we are not really sure the value of n and m is inside the gradient or the y-intercept. Right? So the value of n and m is inside this non-linear equation. So what we are going to do is to transform this non-linear equation to be the linear form, which is y equals to mx plus c. Alright, so for our big y and big X here, we are going to use the axis from our graph. Alright, so our big Y would be ln y and our big X would be small x. Okay, so according to these conditions, we need to transform this non-linear equation to be linear. So one of the things we can do is we can compare the left side first. So as you see here, we don't have the ln. So what we are going to do is to apply ln for both sides. Okay, and based on the logs formula, we can move the power to the front already. Okay, and according to log, because this ln has a base of e, and now you see that the base value and the log value is the same, so means this part would be equal to 1. Right? So the right side would be just m over n x plus n. Right? And now you can see it satisfies both criteria. The big Y is ln y, the big X is small x. So now you can compare and you can see that the gradient is m over n and the y-intercept is n. Okay, so now for the first part, we need to find the value of n, and just now we have already found the y-intercept, which is negative 1 over 4. So this would be the value of n. Alright, for the gradient part, we still haven't find this, so let's go back to the graph and find our gradient. So to find the gradient, we need to find out 2 points which are on the best fit line, not the points that which we have plotted just now. Okay, because as you can see, if I select this one, it's incorrect already. The gradient is not this line. Alright, so when we select points, usually we would select the points which are on the thicker lines on the graph, right? For example, this one, and the lines which are at the middle of the box here, right? For example, this line. Okay, so the first point would be this one, right? So if I zoom out, and then you can clearly see the coordinates already. So for the x coordinate, if I look at below, it's 7. And if I look at the left side, the y coordinate would be the middle of these two values, which is 2.75. Right? Easy to find out the coordinates. And for the second point, I'm going to find another point which is far away from the first point. So let me focus here, and let's select the x-intercept. Right? Because again, it's easy to find the coordinates. So the x coordinate here would be 2.4, and since it intersects the x-axis here, so the y value is 0. Okay, so now we can find the gradient according to these two coordinates. Okay, but first we need to draw a right angled triangle according to the 2 points here. So the right angled triangle would be something like this. But why we need to draw this is because for the gradient formula, which is the y1 minus y2 over x1 minus x2, that formula only can be used for for straight lines, right? So if we want to use that formula, we need to prove that this side is also a straight line. So as we know, for right angle triangles, this is a hypotenuse, and hypotenuse are straight lines, right? So by drawing this right angle triangle, we have proved that this side is a straight line, and then we can use the gradient formula to find out the gradient. So these are the coordinates of the points that we have selected just now. So let's find out the gradient, or the value of m over n. Okay, so let's use the formula. So y1 minus y2 over x1 minus x2. So we calculate this, you will get that the value will be 0.509, and here we have the value of n, so I'm going to substitute here and find the value of m. So I'm going to multiply this value to the right side, so value of n will be negative 0.713. Okay, so these will be the answers for part 1 and part 2. So your answers may be different from mine. Reason is because we drawn slightly different best fit lines. Okay, so for the values of m and n, there will be a range of values that will be accepted as answers. So for example, according to the answer scheme, for n, the answers are negative 1.45 plus minus 0.05, which means the value of n can be from negative 1.5 until negative 1.4. Okay, so this would be accepted as answer. So for value of m is a bit tricky because they don't give us a range, it only give us the answer, which is negative 0.7975. So I will assume that the value will be plus minus 0.1 lah. So the value of m can be from negative 0.89 until negative 0.69. Okay, so this will also be accepted as answer. But just to let you know that the range here plus minus 0.1 is just an assumption. Okay, so if for answer schemes that doesn't give us the range, usually what we will do is to make sure our answer is as close as the given answer as possible, right? Because it's too far, for example negative 0.6, right, which is very far from this value, so it will be most likely not an answer. Okay, so please make sure that your answer is close to the answer given, even though there's no range given in the answer sheet. And for part D, we have known that there is one y value which is incorrectly recorded, which is the third point, right? Which is this one. And now they say they have changed the value of y to be 2.14. Okay, so this 1.55 will be changed to 2.14. So now they ask whether this new y value is accepted or not, and we need to give a reason why. Alright, so to do this, why not we find the ln y value of the 2.14 first, okay? So it's 0.761. So now let's go back to the graph and we plot this new point to see whether this point is closer to our best fit line or not. So x equals to 3.7 would be this line, right? And the y coordinate now is 0.76, so the point here would be somewhere here already. So now you can see that this new point is very close to the best fit line. So this proves that this new y value is accepted as one of the y values, right? So to write out our reason, we can look back at the same line, x equals 3.7, and compare the values on the best fit line and the y coordinate of our point. Okay, so from the best fit line, the y value here is 0.8, right? So compared to our y coordinate value here, the difference is very small. Okay, so this can be the reason that why we accept this new point as our answer, because the difference between these two is very small. So here we can write out in this way, we can say yes, because the difference of the value, which is 0.76, to the value on the best fit line that we have drawn is 0.8 is small, right? And then you can just write out the difference between the two values here, right, to show that it is very small. And the next question is the first question in section C, which comes from index numbers, and these are the formulas used in this chapter. Alright, and I would say that for this chapter, the most confusing part is the years, right? So for example, for the price index formulas, we need to substitute the prices according to the type of the year. So for P1, it would be the specific year. For P0, it would be the base year. But I just want you all to focus on the base. So to understand base, let me give you an example. So let's say I want to know whether my height is tall or short. So the only way to know is to compare to a person, right? So the base would be the person that I want to compare to. So coming back here, if let's say this sentence, price index for the year 2022 based on 2021, this means that the prices in 2022 I want to compare to 2021. So means the prices of 2022 will be put on top. For the prices in 2021, I'm going to put at the bottom because this is the data that we need to compare to. Okay, so this is the base year. So now in part A, we need to find the value of X and Y, which is here. So now we have the price index ready, so we can just use this formula to help us. Alright, so let's find the value of X first, which is the price for ingredient A. So let me use this notation. So this will be the price index of ingredient A on year 2022 based on year 2021. Okay, so the prices from 2022 will put on top, which is X. The prices from 2021 will put at the bottom, which is 3.2, and I'm going to put a multiply 100 here, and now I'm going to substitute the price index here, which is 115, and I rearrange this equation to find the value of X. For Y would be the same thing, and the same way we put the values according to the price index formula here. Okay, and I'm going to substitute the value of the price index, which is AT, and find the value of Y, which is 1.5. And for part B, we are given the price of ingredient B decreases by P% from 2022 to 2023. So this is actually a percentage decrease, and usually we can form a price index. Alright, so here we are focusing on ingredient B, so our price index will be IB. Okay, and this percentage decrease, to change it to the price index, we can use this table. So since here it says decrease, so means we can use this one. Right, so means 100 minus the percentage value. So here will be 100 minus P. And here it says from 2022 to 2023, so means I'm using the data in 2023 to compare the data from 2022, which is why 2022 is the base year. So here it will be 23/22. Okay, and we are also given another price index with the same ingredient, so here will be IB, and it is using the data in 2023 based on 2021, so here is 23/21, and the price index is 114. So now we need to find the value of P. Alright, so value of P is the price index of this lah. Alright, so now we have two similar price index which focuses on the same ingredient. So how are we trying to find another price index for it? Alright, so to use a price index to find another price index, we can use this 3-step method. Alright, so the first step is to find two similar price index according to the years stated here. So the years stated here, we have 2023, 2022, and 2021. So we need to find two similar price index which focuses on ingredient B to find out this value. Alright, so we have found one already, and now we're going to find another one which we can find it from the table here. Right, because as you can see, the year stated here is in these years stated here, right? 2022 and 2021. So we can use this price index to help us. Okay, so now we have obtained the two similar price index. Then we are going to go to the second step, which is to arrange the years stated here. Okay, stated in this question. So we are going to arrange it from the latest years to the earliest years, which we have done already lah. Okay, but let me write out here. Okay, 2023, 2022, 2021. And the last step is to use the formula. So this formula is the price index formula. But for the I, the P1 and the P0, I'm going to change all of them to the price index of ingredient B. Okay, and now for the years, what I'm going to do is something like this. So for the left side, I'm going to use the first 2 years here, which is arranged in step 2. So it will be 23/22 here. And on the right side, I am going to split these 2 years. So 23 will put on top and 22 will put at the bottom. And for the blank spaces here, I'm going to use the last year that we haven't used yet, which is 2021. Okay, so now according to the price index stated here, I'm going to substitute the values and to find the value of P. Okay, so the price index for 23/22, it will be this one, 100 minus P. So I'm going to put it here. So we simplify it and we can find the value of P, which is 5. So this method is like a shortcut way to help us find one of the price indices by using similar price indices. Right, so for example here, all are based on ingredient B. Okay, and this method is actually stated in page 275 in the textbook for both versions, BM and BI. Right, so y'all can check it out. And for part C, here it says the cost of one packet of bread increased by 12.5% in the year 2022 compared to year 2021. So since this is a percentage change, then we are going to use this sentence to form an index. Alright, so the thing we are focusing on now is one packet of bread, so it's not focusing on one of the ingredients here, but all of the ingredients here. So we cannot use individual price index anymore. We are going to use the composite index. Okay, because this is the index that it combines all the index together. So we are going to use this notation. So I with a line on top. And now for the percentage increase here, we are going to use this one. Alright, so 100 plus the percentage value, which is 112.5. And for the years, so here it is using the year 2022 and compared to 2021. So means year 2022 based on 2021. So here will be 22/21. So now we are using the composite index, so we need to use the formula for composite index. So here for the I and W, so I is the price index and W is the weightage. So weightage means the importance of each of the ingredients here. Okay, so you can see that weightage for ingredient A is 4, weightage for ingredient B is 3, so means A is more important than B. Okay, so now for the numerator part means that I need to multiply the price index and the weightage for each of the ingredients here, and then I'm going to add them up together, which is what the symbol here is trying to say. Okay, so we are going to find out all the price index from this table and all the weightage from this table. Alright, so this will be our numerator part. Then for the denominator part, we are just going to add up all the weightages. So here will be 4 plus 3 plus Z. So on the left side, I'm going to substitute the value of the composite index, which is 112.5, and on the right side, I'm going to simplify its value. And for the denominator here, I'm going to move it to the left side, and for values which have Z, move to the left side, everything else to the right, and find the value of Z, which is 1. And for part D, here we have a situation. So it says that this bread is RM7 in 2021. Okay, so let's write down here, in 2021, the price is 7. And here it says that the same bread, the price increased by 10% in the year 2023 compared to 2022. So means from 2022, this price has increased 10% when going into 2023. So now in 2023, this person wants to buy bread for the party and with a budget of 170 ringgit. Right? So now we need to calculate the number of pack of bread that she can purchase. So this means we need to figure out the price of the bread during 2023. Right? So there are a few gaps here. For example, I don't know the price increase from 2021 to 2022. So this change actually it is given in part C, right? Because here it says cost of one packet of bread in the year 2022 increased compared to 2021, right? So from 2021 it increased this percentage. Alright, so now we have the percentage increase, and to find the price, why not we use this formula? Right? Because it helps us to find out the price. Okay, so the formula would be something like this. So from the left side, you can see that I have put in the composite index here, not the individual index, because we are looking at the packet of the bread, which includes all of the ingredients here. So we need to use the composite index. Alright, and we are finding the price from 2021, which means the data which are comparing to. Alright, so the prices in 2021 I'm going to put at the bottom, and for price 2022 I'm going to put at the top. Okay, so we are going to substitute the values inside here. So the value of this composite index will be 112.5, P21 will be 7, and we rearrange to find the price in 2022, which is 7.875. So now if we want to find the price in 2023, we are going to use the same thing just now, right? It's just the years changing from 22/21 to 23/22. Right? So the steps, everything is the same. So for this one, because we are increasing 10%, so the price index here is 110 because 100 plus the value of the percentage. Okay, so here will be 110, and P22 we are going to use the value that we have found just now to find the value of P23. So in year 2023, one packet of bread costs RM 8.66. Okay, so now to find the number pack of bread, what we are going to do is use the budget, divide with the price for one bread. Okay, so it's 19.62, and we know that packets of bread cannot be a decimal, it must be an integer, so I'm just going to write it off. Okay, so why it's 19 is because if I split the decimal out, we don't have 0.62 packets of bread, right? So I'm going to just cancel off this one. So we have just left with 19 packets of bread. And for next question focuses on solution of triangles, and here we have the table of formulas for this chapter. So you all can screenshot this first, so later on you all can do it for revision, and also you all can use it when I'm explaining the questions here. Okay, so in part A we need to find out the angle of BAC, which is here, and we need to remember to write it in one decimal place. Okay, so now I would say that the information given in this triangle is not that much. So what I'm going to do is I'm going to pair the angles and the sides together first. Alright, so for the angle that we are trying to find here, I'm going to pair with the opposite side, which is the 7.1 here. And for the angle 50 here, I'm going to pair it up with the opposite side here, which is line AB. And the 8 cm here, I'm going to pair it up with the angle B here. So if you see, for all the pairs we have now, either they are missing the angle or the length of the side. Right? So here it will be a bit hard for us to use sine rule at the moment. Okay, so to find this angle BAC, what we need to have is a pair that has the angle and also the length of the side. Alright, so to find out that pair, what we can do is to find the pair that doesn't have the length of the side, because for length of the side it's easier to find usually. So the pair that doesn't have the length of the side, which is this one, line AB and the angle here. Alright, so let's try to find the length of AB first. Okay, so in summary, to find the angle of BAC, we first need to find the length of AB. So to find the length of AB, and if you look at the angle here, the sides between the angle, their length is provided. And between the two lengths, the angle is provided. So this is actually an indication we should use the cosine rule to find the line AB. Because here, one of the situations that we can use is two sides and the included angle. So two sides would be these two lines, AC and BC, because their lengths are already given. And the included angle would be the sides which has the length and it is between them. So this is the included angle. So with the two sides and the included angle, then we can use the cosine rule to help us find the line AB. Okay, so let's use the cosine rule. So for cosine rule, we need to make sure that the small a and the big A here comes from the same pair, right? Which is line AB and the angle C here. So for the small a, I'm going to put AB. Okay, and for small b and c, I'm going to put the length of these two sides. Alright, and for big A, I'm going to put the angle here, which is 50. Okay, so I simplify the right side and then move the square to the other side, then I can get the length already, which is 6.433. So now we have one pair that has the length of the side and the angle. Okay, so now to find the angle BAC, we can use the sine rule to help us. Alright, so for the top left here, I'm going to put the thing that we are trying to find here, which is the angle. So on top of here will be sine angle BAC. And at the bottom, I'm going to put the length of the side for its pair, which is 7.1. Okay, and on the right side, I'm going to put the information from the pair that we have. Right, so sine 50 over 6.433. Okay, so I'm going to move everything to the right side and find the value of sine BAC, and then I'm going to move sine to the other side. So our angle is 57.7 degrees, but I want y'all to do this, which is using the ASTC method. Okay, because for every trigo equation, there will be two answers, right? Like I mentioned in the previous question. So here we need to find out the two answers. So here we have sine, and here it is positive. So the two quadrants we're looking at is these two. So for A will be theta, and S will be 180 degrees minus theta. And theta will be the value where I move sine to the other side. So it's arc sine, ARC sine 0.8455. Okay, so once we calculate this, it will be 57.7. Alright, And for the other value, it will be 180 minus 57.7, so it's 122.3. So now from the two answers here, I'm going to see which one is suitable for our angle in this diagram here. Okay, so if you look at here, looks like the angle here is not going to be obtuse. So obtuse would be angle something like this, which is they are more than 90 degrees. But if you look at this diagram here, it looks like it is not obtuse, right? So we are going to reject this answer. Alright, so our value will be 57.7. So I know that some of you may think, actually the answer we have already found, why need to use the ASTC method? Because sometimes some questions they might ask you to find the obtuse angle of BAC. Okay, so to prevent y'all to forget to use the ASTC method, I would recommend to do this for all the questions, so y'all won't forget to use the ASTC method to find the two answers here. Okay, so and also make sure that your answer is one decimal place, right, as we see here. Part B, we need to find the area of ABCD, which is the entire thing here. Okay, so in this entire thing, we have two triangles. So what we are going to do to find the area is find the area of the first triangle, ABC, and the area of the second triangle, ACD. Alright, so to find the area, we can use the first formula for area, which is this one. Okay, and then you can see that the condition that we're gonna use this is actually same as cosine rule. Two sides and the included angle. So to find the area ABC, we can just use the pattern that we have detected just now, which is using the length of these two sides and the angle between them. Right? So this one would be 1 over 2 times 8 times 7.1 and multiply with sine 50. Alright, so area ACD, same thing as well. We can use this formula, but the issue is there is not much of information here. So what we need to do if we want to use this formula is we need to have two sides and then we need to have the included angle. So we already have one side, so we need to find the other side. Okay, so here to find out the side, we can look at the parallel lines here first, right? In modern maths, you have learned that if the parallel lines can form a Z shape, meaning this one, this Z shape, so means the angle here and the angle here is the same, which is 57.7 degrees. Alright, so now to find one of the sides, what we can do is, as you see, we have one side here, one pair already. We have one pair and we have the angle here. So why not we use the sine rule to find the length of this line. So if we find the length of this line, then technically we have two sides already. Okay, so let's use the sine rule. So for the top left here, I'm going to put the thing that we are trying to find, which is AD, and below I'm going to put its angle. So here will be sine 57.7, and on the right side I'm going to put the information from the pair, which is 8 divided with sine 100. So I simplify everything. AD will be 6.866. Okay, so now we have the two sides already. So now we just need to find the included angle here, the angle which is between these two sides. So here we already have the angle for the other two, right? So we can use the total angle for a triangle, which is 180, minus out these two angles, and then we can get the angle here, which is 22.3. So now we have the two sides and the included angle, and we are just going to substitute it here. Alright, so we are going to multiply A and B, which is 8 and 6.866, and sine 22.3. So here, once we simplify, then we can find out the total area, which is 32.177 cm square. And for part C, we need to draw a similar triangle ADC and using these conditions. So let's use the 3-step method to draw the similar triangle. Alright, so the first step is to find the unfixed side. So according to this condition, it says that the new point of C lies on the line AC. So if we imagine this new point C is somewhere here, this means that the old point of C will need to change and move it to here. If this point moves, this means the line also will change, right? Which means this line AC is the unfixed side because we need to change it and we need to adjust this C to be here. Alright, so line AC is unfixed. So going to the second step, according to the unfixed side, we are going to find the unfixed angle. So according to the angles which is attached to the side, which is A and C, we need to find which one is unfixed. Okay, so here, in this condition, it says that angle CAD is fixed. So means the angle C is unfixed. Alright, and going to a third step, according to the unfixed angle, we are going to see whether it is obtuse or acute. Alright, and according to obtuse or acute, we are going to draw the triangle to the inside or the outside. So in part B just now, we have found out that the angle here is 57.7, so this is a acute angle. So we are going to draw the triangle to the inside. So inside means that for the unfixed side here, I'm going to move it to the inside. Alright, shorten it to the inside. So this would be our new triangle. Alright, and I'm going to label the points A prime, C prime, and D prime here, because here the question it says A prime, D prime, C prime. Moving on to question 14, focuses on linear programming. So in part A, we need to write out the 3 inequalities as usual. So let's identify what is X and what is Y first. Right? So X would be the participants in the water rocket competition and Y would be the participants in the robot car race. Okay, so to write out inequalities from a paragraph, we are going to find the sentences that mentions total or compares the value of X and Y. Alright, so if we look at the first sentence, this one is just saying that they are having this carnival, so there's not much of information. The second sentence is also saying not much, it's just saying the types of competitions only. Alright, the third sentence, it says that both activities have a maximum participation of 70 people. This is the total number of participants that we cannot exceed. Right? So the total participants would be X plus Y and then cannot exceed this value. So the first inequality would be X plus Y lesser than or equal to 70. Okay, so this is the first inequality, and now going to the next sentence. Here it says that the number of participants of the water rocket competition, so water rocket is X, it must exceed 15 people. Okay, so this one will be the total number of participants that we need to exceed. Okay, so this one will be X greater than 15. Okay, this one is not greater than equal to, this one is greater than, because it says exceeds, it needs to be more than this value. Okay, so please take note, yeah, this is greater than. Then for the next sentence, it says that the participants of the robot car race, which is Y, is at least 1/3 of the participants in the water rocket competition. So water rocket is X. So now you can see they are comparing Y and X. Okay, so we can form another inequality here. So here it would be Y at least would be greater than or equal to 1 over 3 of x. Okay, so this will be our third inequality. So now we have these three inequalities, and then we can go to part B. For part B, we have 4 sections. So the first section is the axis, second section is the lines, third section is above or below, and the fourth section is region. Right? So for the first section, which is axis, means that we need to draw the axis according to the scale given here. Right? So here it says 2 cm to 10 participants for both axes. Right? So 2 cm means one big box, and one big box will be 10. So for the other values here, we are just going to add 10. Same goes to the y-axis as well. Okay, and now we can go to the second section, which is the lines. So meaning we are going to draw these inequalities onto the graph here. So the easiest way to draw the lines is to find out the x-intercept and the y-intercept. Okay, so here for the first inequality, to find out the x-intercept, we are going to put y equals to 0 to this inequality here. So you can see that x is 70. And now to find the y-intercept, we are going to put x equals to 0. So if 0 is put here, then you will also see that y is also 70. Okay, so we can find where x equals to 70 and where y equals to 70 onto the graph, and then join the 2 points to draw the line. Okay, for the second inequality, it's actually a vertical line, so we are just going to draw x equals to 15 onto this graph. Okay, and for the third one, if you use the method which is finding the x and the y-intercept, you will notice that the x-intercept is also the y-intercept. Okay, so if this case happens, what we can do is we find a random number and we substitute it here to find another point. Okay, so let's say we substitute y with 10. So 3 move the other side, here will be 30, so x will be 30. So I'm going to join up the points 0, 0 and the point 30, 10, which is here, and to draw the line. Alright, so once we draw the 3 lines, it will be something like this. Okay, and also please make sure to label the lines. Right, so when we label the lines, we are going to use the equation of the line. So as you can see, I will be using equal sign for all the labeling here. Right, I'm not using the inequality sign because here we are labeling the lines, so we should label based on their equation of the line. Okay, so please make sure to put the equal sign. Okay, and there's another thing to let you know, which is this line. So as you can see, this line is drawn in the dotted line format. Reason is because of the inequality sign. So recall back, for inequality signs which is greater than or lesser than, we need to draw the dotted line. Right? For signs which are greater than or equal to or lesser than or equal to, we are going to draw the solid line. Right? Which is a line that does not have any blanks in between. Okay? Which is something like this. This is a solid line. So this is for the second section, and now going to third section, which is above or below. So above or below means that for every inequality here, which are the regions that satisfy the inequalities here? Is it the region above the line or below the line? For the line here, because it's a vertical line, so we are going to look at regions which are to the left or to the right. So here we need to figure out which of the regions that satisfy these criteria. Okay, so here let me give you a tip on this. So for the value of y here, we are going to look at its position of the inequality sign. If let's say y is on the greater side of the inequality, we are going to look at the region which is above the line, or the region which is to the right of the line. If y is lesser than, we are going to look at the regions which are below the line or to the left of the line. Okay, so going back here, for the first inequality, you can see that this value of y is on the lesser side, right? Because 70 is greater than y. So for this inequality, we are going to look at the regions which are below the line. So according to the graph here, we are going to look at the regions which are below the line. For the second inequality, we don't have the y, but it's okay. We will just imagine that y is x, right? So now you can see that x is greater than 15, so it is on the greater side, which means that we are going to look at the regions which is to the right of the line. Okay, so here I'm going to look at to the right of the line. And for the third inequality, you can see that y is on the greater side, right? Because y is greater than or equal to 1 over 3x. Alright, so we are going to look at the regions which are above the line. Okay, so this is for the third part. And now going to the fourth part, which is to find our region. Okay, so based on the graph here, let's identify all the regions that we can see here. So these are all the regions that we can identify with, and now I'm going to eliminate them according to the arrows that we have drawn here just now. Okay, so let's start with the first line, which is this line. Okay, so we need to look at the regions which is below the line. So for those which are above the line, we need to eliminate them. Okay, which is this one, and this one. So this is for the first line, and now for the second line, we are going to look at the regions which are to the right of the line. So for those which are on the left, we are going to remove them. And now for the third line, we are going to look at the region which is above the line. So means this one I need to remove. Okay, so this would be our region R. Okay, so now we are going to shade it and then label it with the letter R here. Alright, so this would be our region R. Okay, so now let's go back and to solve the questions in part C. So for part C, we are given the registration fees for the both competitions, which is 15 and 10 respectively, and it says that the total expenditure or the total cost is 1200 RM. And here it says that only the registration fees collected are used to cover the cost. So now we need to find the maximum expenditure or the maximum cost of this situation. Alright, so we are now finding the maximum expenditure or the maximum cost. We need to relate it to the graph in part B, because in part B, our x and y axis, we are using the number of participants. So we need to find a relationship between the cost and the number of participants. So let us find the relationship. So let's say if we imagine if we have low cost, this means the registration fees that are collected would be high, which means the number of participants are high. But since now we need to find the maximum cost, this means there would be lower amount of registration fees collected, which means there will be lower number of participants. So this means that if we want to find the maximum cost, this means we need to find the minimum registration fees, right? Because lower revenue, higher cost, right? Okay, so now let's bring our focus to find out the minimum registration fees. Okay, so to calculate registration fees first, we can form this equation because we have the registration fees for both competitions. So here will be 15 multiplied with the water rocket competition participants, which is X, alright, and then plus the registration fee of the robot car race. So it's 10 multiplied with the number of participants in that competition, which is Y. Okay, so now to use that graph, we are going to form a line according to this equation. Alright, so on the right side here, I'm going to put equals to k. So this value of k, you can put any value. Alright, but what I would recommend is to multiply the two values here, the values of x and y. So here the value of k would be 150. So why I recommend to multiply these two values? Because it will be easier for us to find the value, to find the x-intercept and the y-intercept, and then it would be easy for us to draw the line. Okay, so here let me find out the x-intercept. So if I put y equals to 0, x equals to 10, and if I want to find out the y-intercept, here the y value would be 15. Okay, so I'm going to find these 2 points on the graph and to draw the line, and then we are going to find the minimum radiation fees collected. So before we go to the graph, just to let you know that this is actually called the objective function, right? So the objective function is an equation to help us achieve the question's objective. So our objective here is to find out the minimum registration fee. So now I'm going to use this equation, this objective function, to find the minimum point on the graph. Alright, so this is our line of the objective function. So now we need to find the minimum registration fee. So we are going to find the minimum point on this region R. Okay, so to find this minimum point, I'm going to place my ruler onto this line, and then I'm going to push it upwards until the line passes through the first point on the region. Okay, so the first point that I will pass through would be this point here. Okay, so let me zoom in. The point is here. But we cannot use this as our minimum point because it is on the dotted lines. So values or points which are on the dotted lines cannot be used because remember, the condition is x greater than 15 and this line is actually 15. So we cannot use the points on this dotted line. Alright, so what we can do is we can find another point, but it's closer to the red dot here. Right, so one of the choices can be this one, okay, the one below, but as you can see, this point is actually not inside the region, so we need to reject this one. Another point can be on top of the original point, which is here, but still it is on the dotted lines, so we cannot select this one. So the only one that we can select is this point. As you can see, it is inside the region R, and also it is not on the dotted line. So this would be our minimum point. Okay, so now we can find the coordinates of it. So the x coordinate would be 16 and the y coordinate would be 6. Okay, so this would be our minimum point. And let's go back to find the minimum registration fee. Alright, so we have the minimum point, which is 16.6, and now I'm going to substitute back into the objective function here. So we would get 300. So now to find the maximum expenditure would be the total expenditure or the total cost minus the fees collected. Alright, so the answer would be 900. And the last question focuses on kinematics of linear motion, and here are the compiled keywords in this chapter. Alright, so here will be the respective actions that we need to do. Okay, so you can screenshot this table and then you can use it for your revision purposes. And for this table, I'm going to match with the keywords that we will see later in this question. Okay, so in this question we have two particles A and B, and they are moving from different points. Right, start moving from different points. So for particle A, it starts at point P, and for particle B, starts at point Q. Alright, so please make sure of this information here. Both particles, they will move at different points. Okay, so for particle A, they gave us the velocity equation, which is this one, and for particle B, they gave us the displacement equation, which is this, and also they gave us the acceleration of particle A when t equals to 4, it is 3. Okay, so here means if t equals to 4, AA is equals to 3. Alright, and I just want to look at part B, because here there is this particle A moves to the left, so this is one of the keywords in this table. So moves to the left would be V less than 0. Okay, a lot of students will think that this is SA less than 0. They use S instead of V. Okay, so what is the difference between these two? Alright, so let me focus on the difference of S and V. Okay, S is the displacement, V is the velocity. So S in general focuses on the location of the particle. V focuses on the speed of the particle or the movement of the particle. So here it says moves to the left, so this involves the movement of the particle, right? So we will be using V. Why is it not S? Is because, so S here, if you see, it is at the left side of O. So O is the starting point, which means for particle A, it is at the left side of P. But moves to the left doesn't mean the particle is at the left side, right? Because the particle can move to the left, but it is still at the right side of O, right? For example, something like this. O is here, but the particle is here, and it moves to the left. But as you can see, this particle is still on the right side of O. Okay, so we cannot use SA less than 0 in this case. So we are going to use VA less than 0. Okay, again, S focuses on the location, V focuses on the movement of the particle. So here it says move to the left, so we're going to use V. Alright, so coming back to part A, we need to find the value of K. So value of K is the one of the unknowns in the velocity equation of particle A. Alright, so for particle A, we have the velocity equation and we have the acceleration information. So what we are going to do is to change the velocity equation to the acceleration equation. Okay, so according to this diagram, if you want to change from V to A, we are going to differentiate the equation V. Okay, so differentiation we can use the normal way, so 2 move to the front and power minus 1. So here will be 2t, and this one is just t, so I'm going to take out the value of the t, which is negative k, and for negative 6, if we differentiate, it becomes 0. So this would be the result. So now I can substitute the information here into this equation. So t will be 4, AA will be 3, and we rearrange a bit, so k is 5. And for part B, you need to determine the range of values of t, which means the answer that we'll have later will be having inequalities when the particle A moves to the left. So just now we have said that we need to use VA less than 0. Okay, so we are going to substitute the velocity equation of particle A inside here, and then we can change the value of k already, it is 5. Alright, so using this inequality, sub the equation, and now we need to solve this quadratic inequality. Okay, but first, let's find the two values of t first. So here we need to factorize it. Okay, you all can use a calculator. So here, the first one is the value of t is negative 1, and the other one is 6. Alright, so you put the lower value of t here and the higher value of t here. And since this is lesser than 0, so we are going to look at the regions which are below the x-axis, right? So this would be our sector region, and the answer would be t is from negative 1 to 6. Alright, but t is time, right? T cannot be negative. So what we need to do is we need to change the lower limit here. Alright, so what we are going to do is, instead of writing negative 1, what we are going to do is to change it to t will be starting from 0 until 6. Okay, and why we are putting lesser than and equal to? Because when t equals to 0, if you substitute 0 inside this equation, okay, you will obtain VA is negative 6. If negative, this means it is moving to the left side, right? We know that VA less than 0, it is moving to the left side. So at the start of this experiment, it is already moving to the left side. That's why we include 0. And for part C, it says that we need to find out the distance of particle B from P when t equals to 6 seconds. So we are finding the distance from P, which is here, to the location where particle B is at 6 seconds, t equals to 6. So to find out that location, why not we use the displacement equation for particle B and we substitute t equals to 6 inside to find the location. Alright, so once we substitute 6, we'll find out it's negative 84. So what does this mean? So since particle B uses Q as a starting point and the displacement value here is negative, this means this particle B is on the left side of the starting point. Alright, so it can be somewhere here. Right, so let's say this is point C, and this is where particle B is at when t equals to 6. Okay, so now to find the distance, because here it says 84 meters, which means from the point C here until point Q, because it uses Q at the starting point, so this distance is 84. So now we are trying to find the distance from here until point P, so means we are going to use 84 meters and plus 10 meters. Alright, so our answer will be 94 meters. And for the distance, we are not going to use the negative because this is just telling us that this particle B is on the left side of the starting point. For distance, we don't use negative because it is distance, right? It should be positive. So that's why here you'll be using 84. And for part 2, it says that we need to find out the time when both of the particles have the same displacement from point R. So this means we need to find out the t, right, the time that both of these two particles are equally far from point R. Okay, so this we need to look at the location of particle A and B, right? Because we are looking at the distance from point R to their location during this time, the point T which we are not sure yet. Alright, so since we are looking at the location, we should compare the displacement equations for both of the particles. Right, so SA equals to SB because they have the same displacement from point R. Alright, so now we need to obtain the equation for both particles. So for SB we already have, which is here, but for SA I think we don't have. We only have the velocity equation for particle A. So to obtain the displacement equation, we are going to integrate B to get the displacement equation, or S. Okay, so now we are going to integrate the velocity equation. So now we can use the normal integration way. So we're going to add 1 to the power and divide with the new power, which is 2 plus 1, which is 3. So it's something like this. And for the power here, same thing as well, add 1 and divide with the new power, so it's 1 plus 1, 2. And for the 6 here, I'm going to add a t, so here will be negative 6t. And for the range of values here, we don't have it, so here we need to add a c. So to find the value of C, let me go back to this diagram. Alright, so as we know, these two particles have different starting points, right? And in our question, we are finding the time where they have the same displacement from point R. So it's good that these two particles have the same starting point, or meaning they would just refer to one starting point. Okay, so what I'm going to do here is for the starting point of particle A, I am going to change from P to Q. Okay, so everything now refers to Q, and the displacement of these two particles will base on point Q. Okay, so it will be easier for us to track their location and to see whether they have, and to see whether when they will have the same displacement from point R. Okay, so to do so, we can look at the start of the experiment, or meaning when t equals to 0, we can see the location of particle A from Q. Right, so based on Q, we can see that this particle A is to the right of Q. So for the displacement of A, it will be a positive value. Okay, and the distance by how much? It's 10 meters. So t equals to 0, S of A is equals to 10. So why we are doing this again is because we want to have just one reference point to determine the location of these two particles. Okay, so now we are going to use this one, and I'm going to substitute in this equation here to find the value of C. So now if we use Q as the reference point for both particles, we can use this information and we substitute inside this equation. So t equals to 0, it will cause everything here to be 0. So now it's C equals to S of A, and we know that S of A equals to 10, so C equals to 10. And this would be our SA equation, right? The displacement equation for particle A. So now we have the displacement equation for both particles, then we can use this and compare the equations. Alright, so I'm going to move this to the left side, alright, and I want to remove the denominator here and the negative here. So what I'm going to do is to multiply negative 2 for the whole equation, right? So it will be something like this, and now I'm going to factorize it because this is a quadratic equation. So you can use the calculator to find the two values of t, right, which is 10 and negative 2 over 3, but again time cannot be negative, so we are going to reject this value, and our answer will be t equals to 10. And with that, we have completed the discussion of this paper. Alright, so if you have any questions regarding this video, please put your questions in the comment section below. I'll try to reply as soon as possible. Alright, and I know that now you are having your SPM right now, so I wish you all the very best on your upcoming papers. And this will be the last video that I'll be doing for this round, so I just want to take the opportunity to wish you again all the very best on your upcoming papers, especially at maths. Right, so for those like hard questions, I will pray them to go away and to attract like those easy and simple questions for you to score well. And some final thoughts, so thank you so much for watching the videos that I've made throughout the year, and I hope you all have learned something from those videos, which is my biggest wish. Okay, so please do take care of yourselves, and I wish you all the very best on your SPM and also in your future lives as well. Okay, so that's all for now. Bye bye.